Hey everybody, this is Larry. This is day 24, fourth of the Leetcode Day Challenge. So hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Today we're at 564, find the closest palindrome. It's a hard problem, so not so good. Oh, I did it only 2 years ago. Okay. I mean, it's fine. It's just that, what was I going to say? I'm a little bit tired, I guess. I just ran a couple of miles and went to the gym, but I don't know. I think honestly, I've just been a little bit tired because I've been not giving myself proper rest. I think I say this because it also applies to Leetcode, right? Because I've talked about this in the past, maybe not like every day, but that sometimes if you keep on pushing yourself hard, you need a break. Right. And honestly, I haven't been giving my body that, especially since a couple of weeks ago, I did 32 miles. I think honestly, I haven't quite let my body recover. So yesterday I had a tough 10 miles and today I'm still a little bit not recovered. But it's the same with Leetcode, right? You have to, I know that we focus on problem solving because that's the part that we can action on, right? But, or at least I can action on. But, you still have to, eat well, eat a lot of veggies, a lot of fruits and stuff like this. Your brain wants glucose, your brain wants just the sugar, maybe not too much sugar, but it wants some sugar. And of course you want to sleep, right? You want to recover your body to kind of like, does a lot of learning when you're asleep. No one knows how that works. Maybe I'm making things up, who knows? But I don't think anyone's going to debate that you need more sleep. And I think just talking about myself, when I was younger, I did not respect the recovery aspect of both the gym and or learning in general. I just didn't sleep that much. I thought I could do anything, but I don't know. But okay. All that aside, my point is that I need to sleep more, eat more, and also rest a little bit. And I have a video on streaks, right? And streaks are okay, but sometimes certain days just do a easy problem to keep the streak going. Because if you do a hard problem that takes like 3 hours of focus every day, you're gonna get burned out. So just do an easy problem. Get your muscle, get your brain muscle just like a little bit, teased. But you don't have to go hard every day, especially if you have a training plan that you kind of honed over time. Versus if you have an interview next week, then that's a little bit tougher. Anyway, let's take a look at today's problem. It's 3 minutes in. Let me know in the comments what you think about my tips. But 564, finding the closest palindrome. Let's go. Given the string n representing an integer, return the longest integer. N that length is at most 18, which fits in the long. Don't know why they choose it this way, honestly. I meant a 64-bit int, right? But because I think it probably could be better, closer. Okay. So the tricky part is that I think this is one of those tricky problems where like there's just a lot of edge cases, right? I think that's it, really. There's just a lot of possible edge cases and, cheating a little bit. You saw that even in the past, I got 2 wrong answers. So hopefully today we beat that. But if it doesn't, maybe it is what it is. Okay, so, the closest integer, so that prompts me to kind of think about the next biggest one and the previous smaller one, right? Or the next smallest one or whatever, or the biggest that is smaller than and the smallest that's bigger than, right? So okay, I think the first strategy, just to play around with examples, that's how I always just explore things if I don't have any good ideas. I think the very natural thing you want to do is to kind of just take half of it and then flip it, right? I think that makes sense. But in a greedy, or like in just we know that a palindrome exists. There will always be an answer, right? Because, if nothing else, a 1 digit will always exist. So then now, I don't know, I'm just going to bang on the thing, right? So then now we take half and then we mirror it, right? To make it a palindrome, and then we kind of get the delta. But is this really the next smallest or biggest if it pans out, right? Like, is that, I'm trying to think whether that is, I think that's the thing that I'm trying to prove, or at least have some confidence about, is whether this number is either the next biggest or next smallest or whatever. Like, is there a, given this mirror, does it exist a next thing that is in between, right? And I'm just thinking about it right now. I'm gonna get some water while I think about it. Not doing anything, just like right here. I want to say I don't think so, but I don't have a strict proof. I mean, I think that was my intuition. The reason being that there is some like almost like an intermediate value thing, right? Where if you change this to a 4, so the smallest change that you can do is here, because by definition we change this one even just to like a 0, 1 up or down. It changes more numbers than that. Like this has more digits, right? So then now if we do something like that, this will be, you know, in the between, right? And I don't think that you can do it. One thing that, I mean, so that is maybe the case for a particular number. I think there is also maybe an edge case that we have to think about a little bit, is I want to say maybe it's all this, but then it would just be like whatever, right? Because there is definitely also that. So there is a case in which the next number is going to have fewer digits, so we have to warn out for that. And there might be a case where the next biggest number. Now, I was going to say there's a case in which you can have more digits, but I don't think that's true, right? Well, I guess the only way that's true is if it's all 9s, because it cannot be the same. So the next digit has to be, you know, 1 bigger in that case, right? So there are a lot of weird cases for sure. Yeah, the reason why is because, yeah, but because all 9s is always going to be a palindrome. Any number that's smaller than this number with the same number of digits, the next number is going to, like if you have, but I mean not the next necessarily, but something like this, the next number is always going to be this, right? Or even if you have, like, I mean, you can have numbers that are, you know, like this, and that's fine. But after that, or whatever, right? I know that I'm a little bit hand wavy, but I'm just trying to suss out all the edge, or not maybe all of them, but as many edge cases as I can. So my initial strategy is going to be to take the half, mirror it to get a number, still take the first half, and maybe add 1, and then mirror it, and then maybe subtract 1, and then mirror it to kind of get, so then now we have 3 numbers, and it should be easy to see which one is the closest one, right? This is an edge case. But in a similar way, right? I just want to also say, in a similar way, because 10001 is a palindrome, you almost never go below a digit, right? The only time you go below a digit is here, if it's a power of 10, because, and that's only by the tie-breaking rules that you go lower a digit. Okay, so that means that the answer will always have the same number of digits, except for in something like this case, right? And in this particular case, we brute force 3 numbers based off the first half of the digits. Excuse me. And I don't think that you can go any lower, right? Just because by definition, if you change if you change the first digit, obviously this is just a ridiculously big number in terms of delta. If you change even another digit, it would by definition have bigger change than the other one. So this is the only time, right? So you go down, you go up, and that should cover all the cases. All right, let me try it a little bit. I honestly, if you ask me how confident I am, I'm not that I'm not confident that I'll cover 100% of the cases. I'm confident that I'll cover a good amount of cases. So all right, let's play around, right? And of course, there's some odd even thing, but don't think that changes anything that much. Yeah, I think all the rules still applies, right? So okay, so we'll write the general case first, and then we'll write these cases later. Yeah, and here, yeah, we don't have to worry about this going with 9999 as the upper bound. We don't even have to, like, the same algorithm applies, just take half and an increment. It should not go over anyway. I mean, I guess if it's all 9s, then it might go over, but yeah, then that means that it would already have it, so I'm not that worried. Well, yeah, I mean, if it's all 9s, then we have to get the next number. So, okay, there's some if statements in there, but I feel like maybe that should be good enough. So let's play around with that. Yeah, we're 12 minutes in. So yeah, so let's just say first half is equal to n. Okay, so n is terrible. So that's, how do you call it? I'm going to call it P for palindrome. I don't know if that's a good because that's technically not a palindrome, but anyway, over 2 is it so if the way that I always think about, like off by 1s or whatever, it's just I use a real number, right? So if n is odd, then for example n is 5, then this is going to be 2, so which does not include it, so we want 5 to be, so then that should be good. Right, and you could even print it out just if you're worried about. We also want to put in some test cases that we are going to use for sure. Almost like a TDD. I wish. I'm going to run it right now. I wish that they don't tell us the correct answer, so maybe we won't look at it. We won't look at the correct answer because it's not important for now. We just want to look at the first half of these digits. Oh! I wrote an extra one. I was like, this is clearly very wrong. So yeah. Okay, there you go. So that should be half of it. I want to say, right? I didn't really count the number of digits. Yeah, so that looks good. That looks what we expect, right? I did actually want it to include the middle digit for odd number, but maybe I don't. Maybe I'm wrong on that one. So actually, yeah, let me just do it this way. And then now we can do, if n mod 2 is equal to 0, we just do that first, and first half plus first half upside down. So then now a candidate is equal to this. Or maybe we just have candidates, right? And then we have candidates dot append this this number, right? Yeah, fine. And that's just using that. And then, as we said, we want the. Why is it giving me a red thing? Oh, weird. And then now we want the first half. I don't know. Naming things is hard. That's what I'm trying to do. And I guess you can even write it this way, really. For delta in -1, 0, 1, then you can do something like naming things is still hard. int, right, something like this, this plus delta, right? What's how with delta, naming things is hard, and then convert it back to a string, just so that you can do something like this, right? And then now maybe print the candidates, right? Just checking things every step of the way. And this looks pretty good. I think this price should have too many digits because it went from odd number of, or it went from 5 digits to 6 digits. But what that happens is that it goes from 10 digits to 12 digits, right? So this is definitely too high. We have to, that's what I meant by like later we have to think about an if statement here, right? Yeah. But it's okay, it's a candidate, it doesn't have to be a thing. So then now else, so same thing, right? Except for the function's a little bit different, so it's odd, right? So then now we took away the middle one, but we, actually, we do have to be a little bit careful in general, because I'm thinking about the 0 cases, but I guess like if you have one, I mean, I guess it doesn't, something like this, then we definitely want it to be 1, right? Which I think we should handle actually. So maybe going down is fine. Yeah, maybe going down is fine. But with odd number of digits, you have to change the middle digit, not the one with the mirror. So that means that we want, so first half we don't change first half, but we want the middle digit. Middle digit is equal to p of n over 2, I want to say, and this is for n is equal to odd. I think this is right. Yeah, and this should be a thing. So yeah. Something like that, right? So then now you have first half, middle with delta, right? And then now we keep on printing. Now that we should have all the which part? Oh yeah, I forgot to convert this back to string though. So then now we have 1 1 1 1 2 1 1 3 1. This is what we expect. As we said, there are some like weird negative cases, so maybe we'll just add an if statement for it, but it should be fine. Yeah. Because it's just a little bit awkward. It may break out parser thing. But it should be that this is one of the possible answers anyway. So I think we're good. On the middle ones, I think we're probably good because you can't go down enough. Unless this is exactly this or this, right? Because if it's this, this will come up as the answer instead of this number. So, but we can actually just hack it. We don't even need to be that smart, because you can think of, I was saying that you can do if statements, but we'll just add it as a candidate, right? So basically here, what do we have? N is equal to number of p's, so then we can just add to the candidates 9 times n. So that means that this is the same number of things with all 9s, and then we also want to do the 1001 case, right? So that means that we have 1 plus 1 plus 0 plus times either n minus 1 or n minus 2. I think it's n minus 1, because you want that to be the, do we want it to be the same digit or going over? I guess maybe both, just to be sure, because the same digit will be n minus 2 for obvious reasons. And then here maybe we add minus 1 as well, just in case. It doesn't really matter, because it, and why I keep on saying it doesn't matter is just because it just adds an extra check, right? This will give us 3 numbers, this will give us 3 numbers at worst, this will give us a 6 number. 6 comparison is cheap enough, right? Like, I'm not worrying about it. I think I have to kind of think about what happens if this is negative. I actually don't know what happens if it's negative. Does that work? Because it's not very often I do, like, you know, -5, say, right? Let's just do hello. Okay, so it just prints nothing. It's not clear what the behavior should be, honestly, so that's why I don't. And it doesn't usually come up if you're good about it. But so now we have candidates, right? So then now we have candidate for in candidates. So we want two things, right? So we want we want to make sure that it's not equal to p, right? So or maybe we also add pint is equal to int of p. Keeping in mind this is Python specific, but this is a 64-bit int, so you should be able to do it. Otherwise, you can also just do you should be able to just do big int math anyway. It's not that hard. It's just subtraction. I'm trying to think whether yeah, I mean it's just some delta thing on things, so I think it should be good. But yeah, if int of candidate. Okay, so then now best is equal to, I don't know, negative infinity maybe? No, infinity, fine. Or best is equal to, say, like, I want to say candidate of 0 is a default case, but I don't think that works in the sense that in the one case where the first candidate is the same number or something like that. So okay, so then now if the number of candidate with the delta is less than best, then best is equal to this number. And I forget to do the best candidate thing, but we also have to double check best candidate is equal to none, right? Doesn't matter. Best candidate is equal to candidate, but we also have to check that n in candidate is not equal to print, right? And you maybe do it in the other way, but whatever. The if statements in the other direction is technically more precise, but yeah. Either way, and then we just have to return string best candidate, and I think that hopefully covers most of the cases. Let's see. This is what, well, okay, so this is right so far. Oh yeah. I did know that I had to do this, but I forgot. Which is that if it's equal, then take the smaller one. I mean, it's such a thing, but okay, fine. So if this is equal and in candidate is smaller than best candidate, okay. Int, is this an int? It is an int. I mean, it is a string, so I said the wrong thing. Okay, still wrong, but okay, so maybe I'm not generating the, oh, this is n, which is good for upper bound, but we also want it for the lower bound, so we want this to be n minus 1 as well. Okay, I was thinking about it, but then I missed it. Okay, so then now this returns a string of 0, because here it just returns nothing, but here it returns a string of 0. So then we do have to do an if statement because it just returns an empty string otherwise. So okay, looks okay for now. Am I confident? Still not really, honestly. So let's give it, I would say give it YOLO submit, but let's actually test some other numbers as well. Let's say 0. 0 should give us 1. I think that's a good one. Maybe 10. 10 should be okay because it will give us 9. Just random number, and maybe all 9s. Can I have leading zeros? Do I have leading? Oh, it's not a leading 0 if it's okay. Fine. I know. I just saw that part, but it's still not a leading 0 technically. But okay, fine. Okay, looks okay. Let's give it YOLO submit. Hopefully we're good. Woohoo! This time we got it right on the first go. I am happy. I mean, I'm as happy as someone who can get this problem. Not that happy, or like but this doesn't make me that happy. But yeah, you've been here for the entire process, so hopefully it is kind of illustrative. Submit again, just in case. What did I do last time? Oh, so I do miss something. What did I do last time? Yeah, so I do kind of do the same thing with -1, 1. I do the middle thing. But I guess I was less aggressive with oh, this is the delta and the thing. That's kind of funky actually. But yeah, I mean, I was less aggressive with this part, and I think that's the only difference, at least in concept. I did forget about this one. This one I feel a little bit sloppy about. This one I don't know. I just kind of forgot about it. But I mean, I was thinking about it, but writing in that way. So I'm like half worried, not worried, but just half annoyed. Anyway, yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Oh, complexity. I mean, all this is going to be linear time, linear space, right? And remember, linear is the size of the input, which is the number of string, which is more obvious when it's given in a string and not just like a long, right? But yeah, this only does 3 things, right? 3 of linear things. So this is linear. This is also linear for the same reason. This does 4 more things that are linear. And then yeah, this only has about 7 items at most, and each of these is technically linear, right? This converted to int is linear, and even just this is linear anyway. So this is like 7 linear. So everything is linear as a result, linear time and linear space. And that's all I have for this one. Let me know what you think. Thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. I'll see y'all later and take care. Bye bye.